Question 1. You have 3 bulbs, 2 in parallel, 1 in series. The switch hasn't been opened yet. At the moment, these 2 bulbs are in series with each other, so the voltage is split into 2. We're assuming they're the same. Now, the moment that you close this switch, you have 2 bulbs in parallel. And it's important to remember that bulbs in parallel, or resistors in parallel, reduces the overall resistance. So, by closing this, you end up reducing the resistance across here, which means that the voltage across this part of the circuit is reduced as well. Now, if we look at the relationship voltage equals current times resistance, voltage is proportional to resistance. So, by reducing this overall resistance, you are reducing the voltage across it, which reduces the energy per unit charge across it. And so, therefore, the brightness will decrease along here. If you open the switch, this stops being in parallel, and we now share this voltage evenly between the 2. This voltage would now increase. This question's similar. 101 ohm resistors are connected to a circuit. All resistors must be connected in the circuit so that the current flows through them. What is the least equivalent resistance you can get in a circuit? Well, as mentioned before, when you put resistors in parallel with each other, the resistance is reduced. So if you were to put 100 of these lamps in parallel with each other, then what you're doing there is you are reducing the resistance 100 times. So work out the least equivalent resistance by working out 100 1 ohm resistors in parallel with each other, which is given here. If you do 1 over 1 times 100, then you're left with a total resistance of 0.010. I hope that makes sense. Question 6. This is a simple resistivity question, and I assume the only reason why you made a mistake was because of the conversion to micrometers. The rest of the question is fairly straightforward. You have resistivity, you're not given the resistance, but you are given the current and the voltage. So, you work out the resistance, which gives you 4 ohms, and then use the resistivity formula to give you the area. Now, once you have the area, you need to rearrange this equation to give you the radius. How do we then convert it to micrometers? You simply divide your value by the prefix, the value of micrometers, which would be 1 times 10 to the minus 6. So you will always be able to convert simply by dividing the value by the conversion factor. So 7.8 times 10 to the minus 5 divided by 1 times 10 to the minus 6. That will give you 78 micrometers. Now this is a tricky question, but once you do it once, you'll know where to look. You have voltage current behavior for 2 resistors. So one of these is ohmic, and that's its behavior there, the straight line, and one of them is non-ohmic with a resistance increasing as the voltage increases. Now, if the power dissipated in each resistor is the same, that means that the product of current times voltage, I times V, is equal what voltage must be delivered to the cell. So you need to find on this graph where current times voltage would be the same. And if we can see here, at 5 amps, both of these resistors have a current of 5 amps flowing through it and a voltage of 5. So if you work out the power of both, they would both give you 25. 5 times 5. So what is the voltage that must be delivered by the cell. Now there's another layer of difficulty. You've figured out that each component has 5 amps and 5 volts going through it. The resistors are connected in series. That means that in total, the voltage of one resistor plus the voltage of the next resistor is the voltage that must be delivered by the cell. So therefore the total is 10. The circuit below has a voltage of 100 volts and 100 ohms. The battery has negligible internal resistance. Determine the power output of the circuit. The power output would be the voltage, times, you could either work out the current flowing through the main part of the circuit, or you could use the total resistance. We could use any of the power calculations. So, seeing as we have the resistors and we have the voltage, it's probably best to use the relationship P equals V squared over R. Now, what resistance do we need to use? We need to use the total resistance in the circuit, which is 1 over 2R plus 1 over R. Right, so work that out and then find the total by doing 1 over that total. So that 1 over RT equals 1 over 2R plus 1 over R. And then you add that in series with R. Okay, stop the video and do that now if you got it wrong. Find the resistance in total. Right, you should have gotten a value of 166.67. Now, once you have that, you use that value in here with the voltage, which is 100 volts. V squared over R gives you 60 watts. Now, this is a tricky one. In the circuit below, the battery has negligible internal resistance. By what factor would the current through the battery change if the 2R resistor is removed? Give your answer to one significant figure. So what we're doing is we're working out ratios, right? We're going to find out first what is the current when the current arrangement is in place, right? So what is the current right now? And then we'll do that as a ratio of what the situation would be if you have this removed. Now, let's start with that one because that's actually easier. If we get rid of this, then you're ending up with 2 resistances in series. And so your current would be I equals V over 2R, right? So I equals V over 2R. Now, what's happening at this stage? Well, first we need to find the total resistance. Oh, wrong question. Right, here we go. So let's have a look. That's the circuit at the moment. The total resistance in the circuit is the first resistor plus the total of the 2 resistors in parallel, which is 1 over 2R plus 1 over R to the power of minus 1, which ends up giving us 5R over 3. So that is the current when you have all the resistors in place, right? Then the current when there's only one resistor in there is V over 2R. So what is the ratio of 3V over 5R to V over 2R? And if you work that as a ratio, you should end up with 0.8. Question 10. A current of 50 amps flows through a cross-section of a wire. After 6 hours, what is the total mass of all the electrons which have passed through the cross-section? Give your answer in milligrams. Not sure what the issue is here, but let's go through it. Now, if you have 50 amps, the way to solve this problem is to work out what is the total charge, and knowing the elementary charge, we know that one electron has a charge of 1.6 times 10 to the minus 19 coulombs. So that's what one electron has. So let's find how much charge there is in total and then divide it by that to find the number of electrons, right? So we've got 50 amps, which is the same as 50 coulombs per second. And let's work out how much time that is. 6 hours in seconds. So 6 hours in seconds is 21,600. And so therefore the total charge is 50 times 21,600, which gives us this humongous figure, all right? So if we could divide that by the elementary charge, we can work out how many electrons there are. So we divide that by 1.6 times 10 to the minus 19, which gives us 6.75 times 10 to the 24 electrons. Now that's how many electrons there are. We need its mass. So now we find the mass, which is in the data booklet. The mass of one electron is 9.11 times 10 to the minus 31, right? Which gives us a value of 6.15 times 10 to the minus 6 kilograms, right? Which you would first convert to grams, would be 6.15 times 10 to the minus 3 grams. And then you would convert that by dividing by 1 times 10 to the minus 3. Whenever you need to change into a funny unit, you just divide by it. So 6.15 times 10 to the minus 3 divided by 1.1 times 10 to the minus 3 would give you 6.15 milligrams. I hope that made sense.